Okay, let's do number 4 now. Suppose that we've been given z, the set of integers, q, the set of rational numbers, that is to say the numbers that can be expressed as fractions, and r, the set of real numbers. Here we go, part A. Let's write down an element, so some number, that belongs to r and z. So can you think of any number that is a real number and at the same time it is an integer? Well, hopefully you thought of a number like, I don't know, -4 maybe. Or perhaps your integer is something different, like 17. In fact, any integer is going to work as an answer to this question, because of course all of your integers are automatically at the same time. They must be real numbers, because real numbers are absolutely everything. So this is just one possible answer. Any integer would have been sufficient as the correct answer for part A. Part B. Write down a number or an element, a number, that belongs to our rational numbers, so something that can be expressed as a fraction, and at the same time it is not an integer. Can you think of a number that is a fraction but is not an integer? I can think of one. How about 2/3? For that matter, any fraction in the world would work as long as the denominator is not equal to 1 or -1. Any other denominator, well, actually, I guess that's not true, because now I can think of something like 8/2. That would equal 4. That is an integer. So I guess we've just got to choose a fraction that is not an integer, if it can be simplified, and that's one example. You can come up with your own. Part C. Write down an element that belongs to Q naught. That is to say that we want to write down something which is not a rational number. So some number that cannot be expressed as a fraction. Well, I can think of one as one of our favorite numbers, pi. Pi cannot be expressed as a fraction, and we can see this when we write out the decimal approximation for pi, 3.141596, and it goes on forever. And as we observe the fact that this decimal goes on forever, and there's no repeating section to it, that is the rule for something that is not a rational number. We could have a decimal that goes on forever, but if it's got a repeating number like this, 567, 567, presumably it goes on forever, 567, that would be a rational number because it would be possible to express that as a fraction. But when your decimal goes on forever and there's nothing repeating in it, that is a number that cannot be expressed as a fraction, like pi. And part D, use a Venn diagram to represent the sets Z, Q, and R. So how are these sets related to each other? Well, you might remember that R is absolutely everything. So let's make a nice big circle for R. Our real numbers are either rational numbers or irrational numbers. It's got to be one of the two. And so because R is everything, our rational numbers must be inside. Furthermore, all of our integers belong to the rational number set, because all of our integers can be expressed as fractions. Something like -4, we can write that as a fraction, -4/1. Or 17, the integer 17, we can write that as a fraction, 17/1. And so every integer belongs to the rational number sets. It's just the fractions with denominators of 1. And so here's your answer for part D. And some people might argue that for a Venn diagram, we should have a rectangle around the outside that represents the universal set. But I think that's going to be considered an optional addition, because they only wanted us to show the relationships between Z, Q, and R, and didn't discuss a U in the problem. So no worries if you didn't include a rectangle. And lastly, number 5. In each of these Venn diagrams, we need to shade the region indicated. So let's shade the region of A and B at the same time. What region is inside set A and at the same time is in set B? This, isn't it? One effective technique when you're dealing with these kinds of intersection problems is that you can shade all of A in one direction, and then you can shade your other one, B, in a different direction, and then we will keep the overlapping shaded regions, because that represents the region that belongs to both A and B simultaneously. And there it is, the dark colored one in the middle. Part B, the complement of A intersection B. You remember that the complement is a fancy word for not. That is to say, everything outside the intersection between A and B. We've already established that the intersection of A and B is this middle section. So the complement must be everything outside that middle section. There we go. We've shaded everything outside that middle section of the intersection. So that's the intersection, not the complement of the intersection. Alright, let's do part C. It wants us to shade the complement of A union B. Well, A union B is going to be everything in set A or set B. In other words, we're filling in this entire MasterCard symbol in the middle. So this is A union B, everything inside A or B. So what's the complement? It's everything outside the MasterCard symbol. There we go. And lastly, part D, they want us to shade the region that is inside A or is inside the intersection between B and C. Well, let's work with the parentheses first, like order of operations. Let's first shade B intersection C. So the region that is inside B and C at the same time. So what part is inside circle B and inside circle C? It's this stuff, isn't it? There. That's the shaded region inside B and C. So I've now shaded this second part of the problem. The first part, I need to deal with A, and I'm working with an OR symbol, which means I can keep either or both. The OR is actually very easy to graph because I can just shade immediately both different areas. I've already shaded the second one. Let's shade the first one. Let's shade in circle A. And there we go. That is the shaded region of all of the elements that are inside A or are inside the overlapping part, the intersection between B and C. Here it is. Now let's just have a look at the IB mark scheme and make sure that we did answer these things correctly. So here we are. Number 1A. Yes, that's right, 3, 6, and 9. If you're wondering what this A1, C1 business is, that's a tool that the examiners use, or us teachers use, in order to determine how many marks you should get. A stands for answer, or accuracy. And so you get 1 answer mark for having 3, 6, and 9 as your answer to the list of elements in set A. The C is a mark that's given if you gave your answer and did not show any work. And so in this situation, if you did not show any work, you could still get the full marks because part A was only worth 1 mark. And B, yes, we got this right. The elements 1, 2, 3, 5, and 6, again, worth 1 mark. If you did not show any work, no worries, you still get 1 mark. Let's have a look at part B. And so this is similar to our Venn diagram, I think. Got the 9 on the left, the 3 and the 6 were the elements that belonged to both A and B, and then we were left with 1, 2, and 5. You might remember that I also filled in the 4, the 7, and the 8 on the outside, just because I was a bit paranoid about having to include everything in the universe. But I suppose that if we took the question literally, it did say to list only the elements from A and B into the Venn diagram, and that's what's been done here. And so you'll notice that this one's worth 2 marks. We get 1 mark if the 3 and the 6 are inside the intersection, the overlapping region. And we get 1 mark if all of the other values, the 9, the 1, the 2, and the 5, are all correctly positioned. And as before, if you did not show any work, you could still get 2 marks, which is, in this particular situation, full marks. Let's go down to number 2. Right, looks like we got all of the correct answers here. I'll just quickly guide you through the mark scheme. We get 1 mark for each pair of correct entries in part A. So 1, 3, that's a mark. 4, 7, that's a mark. 8, 9, and that's a third mark. Suppose that you only had, say, 5 of these entries. Well, you've got the first pair and the second pair, but you don't have a third pair. You'd only get 2 out of 3. Part B, 1 mark for the correct answer of 9. And part C, this one's worth 4 marks. So we get 1 mark for first figuring out what A naught must be. We get 1 mark for figuring out what A naught intersection C must be, 6, 7. And then we get 2 marks for being able to combine these successfully together in order to get our final answer of 3, 6, 7, 9. Once again, if the only thing that you wrote down was the final answer, you would still get all 4 of these marks automatically. And so there are some IB questions where you can get full marks without showing any of the intermediate steps. However, I do not recommend that you answer questions with only the answer. Because if you had gotten the answer wrong, and you had written nothing else, you'd get a 0 on that question. However, if you had written some of the previous steps, then even if you get the wrong answer, you qualify for part marks. Alright, number 3. Yeah, that's exactly what we had. True, false, true, true. And you'll see that it's 2 marks for each of these correct answers. If you got it wrong, you don't get half marks, sorry. Number 4. I gave the example -4. They've given other examples of integers, 2, -3, but any integer would have done for 1 mark in part A. In part B, we have to give a fraction, and this is what I was talking about. We don't want a denominator of 1, because then it would be an integer, and we want to make sure that it's only a fraction, but not an integer. And part C, we need to come up with a number that is not rational, cannot be expressed as a fraction. Here's a couple of examples, including the one I gave, pi. So A, B, C are each worth 1 mark. And part D, this is the relationship between the different number sets. You'll see that we've got the number set Z inside a subset of the number set Q inside a subset of the set R. And it says in the notes below that alright, so you get 1 mark for putting Z inside Q, 1 mark for having Z inside R, and 1 mark for having Q inside R. And it said that you could have also added the rectangle on the outside, but if you didn't have the rectangle on the outside, don't worry, you still qualify for full marks. And lastly, number 5. This is the shaded region of A intersection B, the region that exists in both A and B at the same time. And here's the complement of A intersection B, everything outside that intersection. A union B is everything inside both A or B, so the complement is everything outside that MasterCard symbol. And lastly, we first figured out what B intersection C was. It's this region here. And then lastly, we added on region A to get that shaded region.